All right, so this is 6.9 of Taylor. So it says find the equation of the path joining the origin to the point 1, 1 in the xy plane that makes the integral stationary. So our f is just going to be everything that's inside our integral here, with the exception of the dx. So we have y prime squared plus y prime plus y squared. And for it to be stationary, df dy minus d by dt of df dy prime is equal to 0, or Euler-Lagrangian. So all we have to do is follow along. df by dy, well, let's see, we'll get y prime plus 2y minus d by dt of df by dy prime, let's see, that's 2y prime plus y prime is equal to 0. So we get y prime plus 2y minus 2y double prime minus, this should just be y. There we go. Right, because if we do the derivative of y times y prime, that's just y. So this becomes just y prime equal to 0. Okay? So these obviously cancel each other, and we get 2y equals 2y double prime, or y prime equals y. Now, this is just a differential equation. It's a second order differential equation, so it's not too bad. And the solution is a e to the x plus b e to the negative x, which, if you're not familiar with differential equations, it's not too bad because you have a, maybe it'll be easier if you see it like this, d squared of y dx squared equals y. So you have a function, and if you take its derivative twice, you just get that function back. So this is the general equation. But they give us points. So we know y of 0 equals 0, and y of 1 equals 1. So that's given here. It starts from the origin to the point 1, 1. And obviously the origin is the point 0, 0. So using this first bit, y of 0 equals 0 equals a e to the 0 plus b e to the 0. And obviously e to the 0 is just 1. So b is equal to negative a. Solving for b, and I can substitute that in. So y of x is now a e to the x minus a e to the minus x. And we can solve for a now by using y of 1 equals 1 equals a e to the 1 minus a e to the minus 1. I could say then, factoring out an a, e to the 1 minus e to the negative 1, and then I find that a is equal to 1 over e to the 1 minus e to the negative 1. Then I can substitute this in. So now I see y of x equals, it was a e to the x minus e to the minus x. But now that we know what a is, we can substitute that in. So it's e to the x minus e to the minus x over e to the 1 minus e to the negative 1. So you could leave it there if you want, but you can also write this in terms of your hyperbolic trig functions. So sine hyperbolic of x is equal to e to the x minus e to the minus x over 2. So then if we multiply both sides by 2 times hyperbolic sine is just this. And if you let x be 1, you'll get the same results. So sine hyperbolic 1. So essentially what we have then is y of x equals and obviously the 2's will go. And you get y of x is equal to hyperbolic sine of x over hyperbolic sine 1. And that's all there is to this one. So hopefully that